Okay, thank you very much for joining me this evening. I am honored um, to be able to give you some perspective, some insights effectively of how I have passed a good portion of my career in the field, pursuing the field of dendrochronology. So I will begin with a short introduction, well, actually an outline of what the program will begin. I'll begin with a brief introduction to the science of dendrochronology and why it is I find this field so interesting. And I also hope to introduce you to some of the people responsible for informing me on how to comport myself in the science, particularly two people who I met early in my career who had a great impact on my approach to dendrochronology and life. Following that introduction, I hope to entertain you with some pictures and anecdotal stories of some of the adventures I've had in the past 40 years in pursuit mostly of remote forest trees least disturbed by humans. Which is becoming more and more an arduous task today than it was in the past. And at the same time, I hope to dump a little science your way so that you can see that there is some merit into all of these exploits and that I haven't just taken advantage of a very luxurious lifestyle. So we'll begin with some basics, those fundamentals of dendrochronology. Um, and let's see if I can get rid of this. There we go. Well, as you can read, dendrochronology is effectively a tool, one of many tools that ecologists and geologists and others can use to study particular functions of terrestrial ecosystems, not only in the present or in the past, but also in predicting the future. Okay. Some fundamentals. Dendro comes from the Greek word dendron, meaning tree, chronology from chronos, ology, the science that deals with time and the assignment of dates to observations. Using dendrochronological methods, researchers measure various parameters. This particular environmental conditions that either improves or handicaps tree growth. And such conditions, if they're persistent, meaning they are ever present, are recorded in the rings for the life of the tree. Proof of a common and persistent growth affecting condition is the detection of the same effect in more than one tree. Information through the power of replication. Replication is one of the strengths of dendrochronology. One just doesn't go out and sample one tree in one location, but many trees in one location. So going back a little bit of history, who and when did this field begin? We can pretty confidently say that the science of dendrochronology begins with the work and writings of these was returning. So we have Captain and Douglas. What they provide to the science is a foundation for building what are called chronologies, time series of measurements from trees. And in their day, these were simple ring width measurements. Today, we measure many more things other than ring widths from the annual layers of wood. But in the 19th and early 20th century, the ring width was the most common measurement taken. And both Kaptian and Douglas, they understood that due to forces external to the tree, these ring widths were extremely reproducible amongst different trees. And patterns. They could detect patterns that could be used to date trees, one with another. Following Douglas, one of his students who contributes probably the most quantitative gifts to the science is a gentleman named Edmund Schulman. He's most famous also for recognizing the great age of the bristlecone pines. In his day, these trees were known to be the oldest living organisms, sexually reproducing organisms on the planet. But Schulman was also a bit of a skeptic. Steeped in astronomy and statistics, Schulman recognized that was a bit of a skeptic. He identified three fundamental problems in tree ring analyses. And the most important one is the third on this slide. Is there sufficient law and order in these elements to enable accurate long-range prediction of future climate? What he's referring to there is we as dendrochronologists have to question whether or not the same processes that are acting on creating the climate we see today are those processes that operated in the past. It is effectively a question of what's called the uniformitarian principle. And this is in 1930s when Schulman was thinking about this. And it's kind of ironic in the sense that we ask the same question of ourselves now. Could it be that with the perturbated climate system due to climate change, that trees are no longer responding to the climate in the manner that they used to, or that we believe they used to in the past? Now, more closer to my generation, the first of two people responsible for influencing me and giving me sort of my, ethos in the field, my attitude. The first is Fritz Steingruber, who came in 1986 to visit my lab at that time I was in New Hampshire. Fritz, pictured here, one of the most generous people I've ever met, particularly with sharing information. Most patient, most knowledgeable, and had a wonderful way of expressing qualitative measures, qualitative characteristics of forests and tree growth. He was responsible for encouraging me to go on and be a teacher, to continue his work in the United States with expanding the use of dendrochronology amongst the younger generation. The second person who I owe a lot to is a gentleman who I've worked with now for almost 30 years. We first met in 1980s. We realized we had two very strong habits in common. We both loved programming computers, and we both loved dendrochronology. Since then, Ed and I have spent many a day, many a week or month stuck in tents, traveling around the world, bringing dendrochronology to those where we had an interest in working for projects. So let's do a little gallivanting. On the map here, I've tried to locate as well as I could all of the places in the world where I've been sent to collect tree ring cores, to collect information primarily for climate reconstruction. This was my job for about 20 years when I worked at the Lamont Doherty Earth Observatory. I worked for three principal investigators, mostly Ed Cook, but also Gordon Jacoby and Roseanne Dirigo. All of them had one wonderful quality in common. They were very trusting and very generous. They allowed me to plan whatever I thought was reasonable to accomplish the mission. They gave me great latitude. I would spend mostly the fall and spring abroad, summers in the US, and winters, excuse me, fall and spring in Asia, winters in the Southern Hemisphere. It wasn't uncommon for me to be away from my home for 6 months in a year. So we'll do a little trip like one I would have taken. Start New Zealand. It would probably be around January, and I would have packed up. And in this instance, we're going to fly to the very southernmost island of the New Zealand archipelago, and we're going to go to the west coast of that island. This is called Mason's Bay on Stewart Island, and it's most conveniently reached by a small plane at low tide. And what one does is make an arrangement with a pilot to come back, say, in 8 to 10 days at low tide. From New Zealand, we'll go quickly to Tasmania. From Tasmania, we'll hop on a plane to Melbourne, Sydney, and then Denpasar, Bali. From Bali, we won't take a motorbike, but we'll try to get ourselves to Kathmandu. And hopefully we'll end up in Bhutan. These will be the 3 countries that, of the many that we'll visit on this short tour. We'll start in New Zealand. In New Zealand, we were working on 2 large projects. One was led by Roseanne Dirigo and the other by Ed Cook. These were both paleoclimate projects researching deep time climate history in the Southern Hemisphere. The Southern Hemisphere, dendrochronologically speaking, had been explored in the 70s by a professor named Val LaMarche from Arizona. Back in the 70s, Val traveled all over New Zealand and Australia, searching for trees that he could use for climate reconstruction. However, he was quite discouraged by what he found. He found the species there to be very complacent, meaning not much year-to-year change in the ring width. He concluded that since there wasn't much annual variation in the ring width, there must not be much annual variation either in the climate, or that the trees just don't pay attention to the climate. So Val didn't do much with his work other than to establish some species, or to identify some species in some locations. So not much work, dendrochronologically speaking, had been done since LaMarche's forays in the Southern Hemisphere since the 1970s until the early 1990s. And that is when Roseanne and Ed thought to found a collaborator, Jonathan Palmer, on the far right there, running away from the helicopter, and started 2 programs to study 2 species in particular. The species of interest in New Zealand were silver pine and pink pine. Ed was going to work on the silver pine, and Roseanne would focus on the pink pine. On the left, you can see what was a typical annual foray for myself in New Zealand. This happens to have been in 2001. And you can see the number of sites and the amount of traveling that we did, my wife and I in this case, in 2 months in New Zealand. The silver pine, the oldest we found, were on the slopes of Mount Ruapeo. That's the top left image. This is one of the most southern volcano in the Tongariro group in the south of the North Island. The oldest pink pine we found We're in what are called the Ruggedy Mountains. They're on the rough west shore of Stewart Island. They're pictured in the lower left. On the right is a species of tree that has not been dendrochronologically explored until we visited this location for the first time. It's a Orthophagus. It's a beech, a southern hemisphere beech. And that particular individual is 900 years old. And the reason I point it out is because it exhibits what I call stereotypical old growth. The photograph on the left is of a blue beech, a southern hemisphere blue beech, an Orthophagus, and it exhibits the classic old growth form of a spiraling trunk and low, large branches. As I mentioned, this tree is almost 900 years old. So I also mentioned previously, we were in New Zealand, obviously for our own purposes to reconstruct climate, but also to assist a number of graduate students, those that were studying with our colleague in New Zealand, Jonathan Palmer. The silver pine in the west coast of the South Island has adopted a very riparian habitat. It likes to live near water. And for that is a very convenient condition for someone like a dendrochronologist who is looking for to build old long chronologies, because when a silver pine in this instance dies and falls in the water, it can be preserved. So in the South Island, in search of silver pine, we would be mostly working in swamps, using both chainsaws and increment cores to cut dead stems out of the streams and core the living stems on the ground. This was part of a project of a graduate student, Lee Min, who is there on the top right, trying to negotiate a stream. And these are some of the chronologies that Lee Min has produced. For our work with the silver pine and the pink pine, we were largely interested in climate reconstruction, and particularly to see if we could not improve on what Lamarche had written earlier about these species. What I wanted to say is that it wasn't true. You can get a climate signal from these southern hemisphere pines. And what we think, what Val couldn't realize, what we think we can realize is that measuring these ring widths to a higher precision helped. Okay, so we'll go to Christchurch and get on a plane and fly over to Hobart and land in Tasmania. And we've been now just about a month in New Zealand. In Tasmania, the species of interest is Huon pine, one of the most beautiful trees in the world, Lagerostrobus franklinii. Huon pine, again, is another podocarp, another southern hemisphere pine, and it's incredibly special. It contains a wonderful chemical called methylusinol in its wood that acts as a natural insecticide, pesticide. The early settlers, the early farmers of Tasmania cut this tree down by the millions to chip it up and use it as bedding for their sheep. It worked very well in keeping the critters, the lice or bugs or whatever it is that bother sheep in their stables. Today, it is the most protected tree species in Australia. You cannot be in possession of the wood without permission. There are four places where we found, three places where we routinely went in search for Huon pine. Working with colleagues from CSIRO RO, excuse me, in Australia and at the University of Tasmania, we had permission to sample dead and down material and core living. The three locations are the Stanley River, the top left, Lake Petter on the far west coast, the top right, Mount Reed, the bottom left. Yep. From each of these locations, 2,000 to 4,000 year chronologies have been developed, but there's potential to go even further because some of the dead wood that has been preserved under the lakes is over 12,000 years dead. Unfortunately, there's no way to connect yet that wood with the present, but people are working on it. One of the interesting anecdotes about these four sites is in reference to the lower left. As you can see, this looks quite like a bleached white dead stand of snags. In fact, it is. These trees, those trees you see in the foreground, were killed by a fire. But they also happen to be a clone of all male plants. Huon pine is dioecious and also has the ability to clone. So here one could argue you have one of the world's oldest fraternities. When we published a little brief about that in the local Hobart paper, it got picked up by the national news on the continent and spread around the world. And one day we received a call from a representative of Mick and Bianca Jagger who wanted to visit this stand of old men. And I have to say that's only the second time, well, the first of two times that Hollywood has ever interfaced with our science. Or not really Hollywood, but, fame and popular notoriety. These are the trees in Mount Reed in that fire-killed stand. And as you can see, because they are dead, we could have permission, did receive permission to sample them with chainsaws. However, in the Stanley River, the situation is a little different. There in the Stanley River Valley, the old oxbows store a lot of the dead wood. On the picture in the left, there's about a 3-meter hole dug with a digger, and you can see the log that has been cut at the very bottom and the big piece of it up on the bank. That wood has been C14 dated to be 20,000 years dead. On the right shows an actual temperature reconstruction produced from the living trees from this same location. And not only a reconstruction in temperature in time, but also a reconstruction of sea surface temperatures in space and time. And it is rewarding to see that the highest correlations in the lower right color graphic are between the Mount Reed tree rings and the most local Western Indian Ocean sea surface temperatures. There's also an interesting negative correlation developing in the upper right-hand corner of that panel, very suggestive of an ENSO signal or El Nino response. Okay, so from Australia, let's go to Indonesia. Way back in 1994, and I would say, yeah, about 1994, after my first trip to Indonesia, Gordon, Roseanne, and I wrote this small paper suggesting that teak could be used to reconstruct climate, particularly the El Nino and Southern Oscillation from Indonesia. Once again,
You've gone again for some reason.
I hear you perfectly.
You're back now. You're back.
Okay. Once again, this is another example of following in the footsteps of a previous researcher and picking up where they left off. Before us, another scientist, a Dutch scientist who was very interested in cultivating teak in Indonesia, name was Balazs, had noticed that teak tree rings could be measured and that one could build chronologies from teak. And he did so. His chronology that he built began in 1880 and ended in 1929. When we found this information, we thought, well, maybe we should go back and see just what has happened since 1929 to the teak in Indonesia. And maybe if we could extend the Balazs chronology to the present, we might have a very nice record of ENSO, as Indonesia is right under a center of action for the El Nino ENSO phenomenon. Effectively, when there is a El Nino in Indonesia, it's cold and dry. When there is the opposite La Nina effect condition in Indonesia, it's warm and wet. The theory is when warm and wet, the trees will grow well. When it's cold and dry, the trees will not grow so well. And I might want to point out that Indonesia is right on the equator. This is a tropical zone. And at this time, there were very, very few, if any, reliable long chronologies from the tropics. And so here was an instance where there was an opportunity to build a long tree ring chronology, well replicated from a tropical latitude. So we pursued it. And once again, a map showing you the type of travel that one does to. The map in the upper left depicts a typical season of travel in Indonesia, 2 months. Generally, it would start with renting a car in Bali because there it's very easy to rent a car. Actually, no, I take that back. The trip will start in Jakarta. It must always start in Jakarta, where one has to get letters of travel, permission to travel around the Indonesian archipelago. And these are provided by the police, Indonesian police, and by an organization, LIPI, the equivalent of our National Science Foundation or European Science Foundation in Indonesia. They will issue your permissions to travel, a Surat Jalan. Then fly back to Bali and rent a car, because in Bali, there are no natural forests left at all. The island has been inhabited by thousands and hundreds of thousands of people for so long that there really is very little natural vegetation left. However, in Java, that's not necessarily the case. And as a matter of fact, it was on the island of Java, portions of Sulawesi, where the Dutch had established many plantations, particularly of teak, as it was so valuable for boat building. So we rent a car in Bali, drive to Gilimanuk, which is on the west coast of Bali, put it on a ferry, cross over to Wanyabangi, and then drive across Java, stopping at places where we suspected, or there will be still. How would I know where to go? Or how did I know? On my first trip to Indonesia, I spent days in the botanical library in Bogor. And there I was pointed to a cabinet by the librarian. Imagine this beautiful teak room, large, sunny, amazing tropical flowers, plants growing all around outside, very quiet, because no one even then was reading books. The librarian directs me to a filing cabinet, a metal filing cabinet, about 3 meters tall, 1.5 meters deep with steel doors, opens it up, and out fall stacks and stacks of an old journal called Tectona. This was a Dutch publication all about teak. And I started leafing through these journals, and all I could really get from them were pictures and maps. And it was going through these journals that I found a number of places where there were pictures of incredible trees and a map. And so those were the first places I would go. I decided to go, and they turned out to be still some trees in those locations that were quite old. One location in particular, almost in the middle of Java, Saradon, had the oldest known teak trees at the time, 400 years old. And this is what an old teak looks like. And once again, you see that spiral. You see that classic old growth spiral winding up the stem. Indonesia is a very densely populated country, particularly Java, and you cannot go around really freely in Indonesia without support. And I was very fortunate to befriend a family who were extremely helpful in supporting our project. And ironically, the oldest son of this family, pictured in the center with me, is right now in Cambridge doing a master's in engineering. But at that time, Tia Biaksana was a professor at Bandung Technical Institute, and he wanted very much to have a tree ring lab, have the capacity to do dendrochronology in Indonesia. And it was through that experience that I learned how far helping our local cooperators develop the same capacity as we have gets one like myself in terms of access and mobility around the country. I told you earlier I would rent cars. I used to rent a car in Bali. In successive trips when I came to Indonesia, I could borrow Tia's car, and that was extremely helpful. Two of his students, Leode on the top right with myself, and as an extension of this work, my family and I became very close to this one family and the two students, Siti and Ode. And they came even to the US. We brought them to Colombia for additional training. And Siti lived with us for a month in our home when our first child was just born. But as you know, Indonesia is a country of islands, and there are lots of them, which means getting around is going to eventually come down to using boats. On this panel, I points to, if I move my mouse, I don't know if you can see, my mouse is moving right around a little island in the top right corner called Sampanjang. It takes 2 days to get to Sampanjang from Surabaya. Surabaya is a large city in northeastern Java. And these are examples of the various boats that get smaller and smaller as you get further and further away. Here, these islands are coral reefs, and very basic in terms of the pH, and it's the perfect condition for teak. Teak loves growing on old coral reefs. And we were told that we might expect to find some old teak on these small islands. It turns out there weren't any, but a lot of mangrove and a lot of interesting people. But back on Java and Sulawesi, that is where we find the best samples of the species. Here you see the pictures from what were the oldest known teak in the world. Over 450 years, which is quite old for this place, this part. So what have we learned? Well, what we have learned is that the teak in Indonesia contain a very strong record for a tropical species of sea surface temperatures on the western Pacific. The data that we collected in Indonesia, together with corals from Tahiti, trees from southwestern United States, and an ice core from Peru, have used to produce the first spatiotemporal sea surface temperature reconstruction of the centers of action of El Nino, basically the north central Pacific, you see on the right. This was a great find. What this told us is that there was potential to actually study the habit of ENSO, El Nino, not only through time, but also across space in the sea surface temperatures, from the sea surface temperatures that were reconstructed from this multi-proxy project. Okay, so now we're going to go north and head to Nepal. Nepal is predominantly a project of Ed and mine. It came up one day when I was talking with Fritz Steingruber about tree ring studies in the Himalaya. Did he know of any? And he told me the most amazing story, that he had a friend named Rudolf Zuber, who was a trekking guide in Nepal. He worked there in the fall and in the spring, and that he would collect cores everywhere he went in Nepal. And not only a few cores, but quite a few cores. And that this was a large. So Fritz loaned me this collection, this remarkable collection of samples that Zuber had collected in the early 80s to jumpstart a project of our own. And Ed and I wrote a small grant to our small grant request to our National Science Foundation, basically promising to work on reconstructing the Southeast Asian monsoon, the monsoon in general. We promised a lot of things we probably shouldn't have, but we were, it was a hope and a prayer. We didn't think we would get any response, but we did. We got some funding for a few years to go and update these existing chronologies, these collections that Zuber had collected previously and given to Fritz. Had Fritz not loaned us that material, we really wouldn't have had much grist for the mill, or I would say evidence to prove proof of concept. So for the next 10 years, it was my job to go and try and visit every one of Zuber's sites. And there were actually a lot more than are depicted here in this map. There are about 45, and here we have 32. Excuse me, there were 46, and we only ended up collecting 32. But nevertheless, there was funding, enough funding for myself, maybe one other to accompany me, but mostly myself, to go twice a year to Nepal and try to find these same trees. And that was pretty much a full-time occupation. Suffice it to say, returning so often to the same place, you get familiar, not only with the place, but the place gets familiar with you. And I made a number of fantastic friends there. Effectively, the men who I would hire for every expedition. I would go on. The same, these three men were all relatives in the same family. Two are brothers, and one was a cousin, Gopal, our head porter. But we became very close. So twice a year, I would come, would hire them. They would organize all of the gear I needed from local stores, the food, and even hire the porters, some of them who were also family members, which was very convenient because when you're working with a team in the Himalaya or anywhere for that matter, it's nice to know that they all share something in common. And being mainly family members was really comforting. But they're also from the southern Nepal, and you might think, not quite mountain people. Don't you supposed to hire Sherpa? These men are what are called Tamang, and the Tamang were the first immigrants from Tibet to come to the Himalaya, to cross the Himalaya and come to what is now Nepal. They were effectively horsemen by trade, but they did cross the Himalaya, and they settled in some of the finer lands, countrysides for agriculture. The the famous Sherpa, they're the most recent immigrants from Tibet. And sadly, by the time the Sherpa arrived, there wasn't much nice land, arable land left for them to occupy. So they had to settle at the very highest elevations of the Himalaya. But the Tamang are equally capable and very habituated to mountain travel. And it's amazing how much, they can work. These young men would carry 40 kilos all day long with no problem, 60 even if necessary. Um, Along on many of these trips, I brought Ed with me. And this is the time when we really bonded and found that we could work very well together. I don't know if you see that little tent on the right, but that's Ed and my tent. The tent on the left is for start reading Shakespeare in the background. I became very close to the families of these men who were helping me in these expeditions, such that between expeditions, if I was, say, waiting for someone to join me from the US and I had a week or two to spend, I would travel to Sanu's home and stay with his family, maybe work on the home and help them out with the little that I could help them economically. And that was mostly buying things like a water container to put on the roof to collect water, simple things, which I could, easily write off as a disposable equipment on my travel voucher when I got back to the US, that is. But we stayed in touch for quite a long time. We still are occasionally in touch. In this photograph here, we have just installed this water cistern on top of their roof of their home, and we're about to head back to Kathmandu. It's a day's walk to the road, and from the road we would catch a bus and travel for about a day to reach Kathmandu. And this is a small little ceremony, a goodwill ceremony for our travels, wishing us luck. And now what I'd like to do really quickly is kind of give you an overview of what it's like to actually work in Nepal, how one, actually, maybe even core some trees. We're going to go now to the eastern part of the country. In front of you, you see Sagarmatha, Mount Everest on the left. That's the peak. And Lhotse is just visible, and so is part of Nuptse there on the left. On the right is my favorite mountain in the Himalaya, Makalu. And it's on the right. It's at the bottom. It's the base of the eastern ramparts of Mount Makalu, on the right. That has the sun on it there, where we're going to go. The map looks a bit like this. Makalu, the mountain, the peak we just saw in the previous photograph, is up here in the upper right-hand corner. It's the fifth highest mountain in the world. And in 1996, a couple of colleagues of mine from the University of New Hampshire had in mind the crazy idea to take an ice core on the Barun Glacier at 6,500 meters on the slopes of Makalu. And I asked if I could come along, since that was a part of Nepal I hadn't been to, and neither had Zuber, and that it would be great if I could join them, at least partway up their expedition. So together we planned to accompany the ice coring team from all the way to what is basically Camp 6 on this map. I should point out that Camp 1 down here in the lower is 3 days walk from an airstrip. So we walk 3 days, we get to Camp 1 and move on to Camp 2, Camp 3, Camp 4. At Camp 3, we have the first sampling site. That's already 6 days from the landing strip, 7 days from Kathmandu. And the reason I'm making a big deal about these number of days and the eventual day in which you sample is that a 6-to-1 ratio is actually a pretty good ratio for this kind of work. If we can get one good day, maybe 2 good days out of 6, I felt very successful in terms of sampling. The following camps and sample sites come at much closer intervals, because by the time we reach Camp 5, we are getting far enough away from densely inhabited areas that the impacts on the forest by humans is much lower. So we don't have to climb so far or travel so far off the main trails to find suitable trees to sample. I'd like to point out on this map also the small village of Tashigaon, right down here at Camp 2. Tashigaon is where there's a radio station, actually a meteorological station that's operated by the Office of Snow and Glacier Hydrology, where there's a two-way radio, which I had permission to use. I could communicate, if needs be, with other high elevation weather stations in Nepal at every 6 hours from 6 a.m. in the morning to midnight. And I actually did have a need to use that radio, but that's another story. But what I'd like to tell you is, in this same village, there is a monk who has the key to the station. And I was given directions in Kathmandu by a colleague of mine at the Ministry of Meteorology to inquire on this monk to get directions of where trails are and also the key to the station. And when I say station, please don't picture something very nice and shiny built of concrete. It's mud and wood with a little wood stove and electricity. It's actually the end of the electricity service in this part of the world, and a radio. So on the morning of when I was scheduled to leave, I thought I would go find this monk again and ask him if he knew of a trail that could bring me from the Barun Valley, which is here, over to the Arun Valley. I wanted to do this crossing that I'm illustrating in the map. There was no trail there. The only trail that exists, and only map, the one we have here that exists, is this diagonal sort of northwest southeast trail. Everything else you see until we come to the Arun River is actually from this point is what I've drawn, the path I've taken. So I go to the monk, and I have this particular map. By the way, you notice there are no markings of no coordinates of longitude and latitude on this map, and this is the only map of the area. So a GPS is kind of useless here because you couldn't put your points on this map. And I asked him if he knew such a trail. And I got this incredible, beautiful, long lecture that was in a language I never heard, had no idea, but punctuated throughout his speech was the word raincoat. Okay, so I go back to my companion at the time who was accompanying me, and he asked me, "Okay, Paul, so do you have the trail? Do you know where you're going? Or where are we going?" And I had to say to my friend Garn, sorry, Garn, I have no idea where we're going, but all I know is we better bring a raincoat. And sure enough, it was incredibly wet. But what I want to point out is this location here, Camp 9, because it is there that we found the oldest known trees in the Himalaya. And please don't take it too seriously or think I'm being I say proud or anything when I say the oldest known trees in the Himalaya. I'm sure there are older trees somewhere in the Himalaya, but they have yet to be found. And not only found, they have to be determined to be old. As dendrochronologists, the only way we will accept the determination of or the title of an oldest known something is if that age has been determined dendrochronologically. Now, it was in 1996 when I stumbled upon this site, a very unique site for the Himalaya, actually a very level site in the Himalaya. The Himalaya is not known for providing a lot of level ground. And I believe that is the reason these trees have survived so long. If they were growing up on a slope or anywhere else than where they are growing now, they would have long time ago fallen over or been knocked over. But these trees are over 1,000 years old, and we have the proof. However, in the very first trip that I took in 96 there, I only had a 50-centimeter borer, and these trees are well over 2 meters in diameter. So I'm sure they are older than 1,100 years, but the only way to find out is to go back. And one day, I hope to do that. That is, if and hope that they are still there. Okay. Here we go. The last and final venue. For those of you who are still around, still awake, I apologize for all the interruptions. We'll end in Bhutan. And Bhutan is the place where I've been most frequented last. Since 2018, I've not been back, but from 2002 to 2018, I went annually to Bhutan. It is also in Bhutan where I think Ed and I have done our best work in terms of capacity building. And it's also the country where, so Bhutan is the place we learned our lessons well working in many other parts of the world and how to build capacity in a developing country where there is a need for education and where we have a need for information, for access. In Bhutan, we seem to have done it right. But where is Bhutan? For those of you who do not know, yeah, that's that little country there on the right. The capital is Thimphu. Their last count, there was about 750,000 people. And I heard recently that it is a carbon surplus country, I think. Something like that. I'm not familiar. Basically 70% forested. a very unique place. We targeted Bhutan because Bhutan is ideally located, between the sort of two major centers of action in terms of climate. You have an influence of the southeast monsoon coming up over the Bay of Bengal. And at the same time, you have a lot of influence of the Tibetan Plateau, that to the north. To us, to Ed and I, we thought this has to be a really interesting place to study climate dynamics because it's kind of on a hinge point. Here you can see it's more or less the diagram. So Bhutan is here, and here we have these three major centers of action, the three major internal climate dynamic features. As it turns out that Bhutan was also important for us because at the same time that we were building a reputation and building a collaboration with the Bhutanese, we were also working on what we call the Monsoon Asian Drought Atlas. This was to be a large atlas of reconstructed drought over Southeast Asia. And Bhutan fitted perfectly in the middle of that. However, Bhutanese, very shrewd people, very honest and open people, and it was clear that if you want to come and work in Bhutan, you have to bring something yourself to the table. And this we did very well, very successfully. There are two tree ring labs in Bhutan, one at the local College of Forestry and another in the Royal University. Both of these institutions have professors who we have trained in the rudiments of dendrochronology and who have also picked it up. And so in sort of completing the package of capacity building in Bhutan, we've organized a number of workshops and international meetings where we've brought scientists largely from Europe and the US to Bhutan to engage with the young Bhutanese scientists that we have worked with over the years. And this marriage, this union, has led to a number of successful Bhutanese students going on to do postgraduate work in the US, in Europe, and Australia. As a consequence of these efforts, we have become very familiar in Bhutan. It's not a big country, as I mentioned, only 700,000 people. If you go there enough times, you are known. It was not unusual for me to be in the far, far eastern part of the country and run into someone who knew of me or who knew someone who knew of me. That was just because the country is so small, but the connections also work the other way. One of our closest friends, who was when we first met him, a director of a research station, an agricultural research station in central Bhutan. Over the course of our tenure together, our time working together, he became the cabinet secretary. And that was not, well, we never abused that access, but it was nice to know that there was someone, if we needed any help, we could call on and who could help us. But we didn't need that. What we did need were challenges. What we really wanted or sought with every trip were projects that we could demonstrate to the Bhutanese, showing how dendrochronology could be useful. And there were two general areas that the Bhutanese were most interested in. The first, of course, is forest management, with being 70% forested, obviously, and timber wood production, one of the most valuable resources the country, helping the Bhutanese improve their domestic forest practices was very attractive. And as a matter of fact, we worked regularly with the Ministry of Forests, and our MOU, Memorandum of Understanding, was with the Ministry of Forest and Agriculture. The other sector that the Bhutanese, the other yeah, the other area that the other application of dendrochronology that the Bhutanese were really interested in was archaeology, for cultural conservation and cultural heritage purposes. And this was really fun for us because it meant that we could get access to some amazing cultural monuments. These fantastic these zongs are post-medieval period, and what a treat it is, to actually stay in one overnight. Just to be ready to work in the morning. And there was opportunities like that made this kind of work so special. And of course, the treatment and generosity of the Bhutanese we received in return. But as I mentioned, sustainability, forestry, resource management. This was one of the most important concerns of the Bhutanese, by the Bhutanese, and is where we focused a lot of our very practical training. We even tutored one of our first students to write an SOP, a standard operating manual, procedures manual for dendrochronology. Now that in Bhutan, there were two actively working tree ring labs. Some examples of these sort of practical studies, these are classic dendrochronological studies. Scarring from flooding is one way to get a sense of how frequent, say, a stream overflows its banks. When you can date the wound that debris coming down the stream makes when it hits a bank, a shoreline tree. One can take the stream scarring experiment one level higher, one level further, to even calculate the amount of water that came down in a flood, by simply calculating the area under a cross section. A very common experiments done in forestry are thinning trials, where foresters execute to remove prescribed amounts of trees from fixed areas. And some treatments are heavier than others, where they might remove more trees than in another area, and then to come back years later to measure how well the trees that remained grew as a response to the thinning. We've done a number of these thinning trial experiments in Bhutan, and they have, using the information that we provided, determined the right number of trees per hectare of particular species in a particular thinning trial experiments. Very valuable if you're serious about growing timber. And of course, for our purposes, climate reconstruction. Is in Bhutan, this particular species of spruce, Picea spinulosa, it has a reasonably strong temperature, June, July, August, current growing season temperature signal. From that response, we can reconstruct, reconstruct temperature back to the 17th century. This is some of the work some of the papers that have been published, largely from not just the work in Bhutan, but also from the general region, Southeast Asia region, the greater Himalayan region. And that is all. Oh gosh, if there's anyone left listening.
You've still got 27 of your audience.
No
So well
way.
done, Paul. I'm so sorry about the state of the I'm sure it's the volume of traffic on the internet, because it got worse around about 9 o'clock, which I think probably shows that there was just too much contention on the internet.
I'm embarrassed to say it's probably all on my end. I don't know where she is now, but I'm sure my daughter is somewhere in the house.
And well done for keeping going. Thank you very much for all of that. I don't know if anyone's
Oh,
got any questions. If they can pop them in the
I'm gonna stop.
in the chat, or I mean, I can unmute you all, and you can actually. Well, no, I think if you can put them in the chat, that would be best. If I can find my chat, I've gone and lost my chat now. Oh,
So I
there.
stopped sharing my.
Yeah, right. Okay. I've lost the chat. Oh, where have I put the chat? There we are. There we are. Right. Oops, hang on. There we are. Right. So do we have any, does anyone want to, let me put this up on my big screen now, and then I can actually see it. There we are. Has anyone got any questions? I must say, I thought that was absolutely fascinating. I would love to go and have a look at some of those trees in the Himalayas. I think they are really rather exciting things. There are such wonderful trees around the world, and to have had a life where you can actually go and see them, and have everybody sort of helping you do it is just absolutely wonderful. What a lovely life you've had, Paul.
I've been very, 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 very lucky. It's just, yeah, no, I'm humbled by it because it's so fortunate, and sometimes I feel like I won the lottery without buying a ticket, in many respects. But yes,
So are the trees, I mean, of all the areas that you've been to, which areas do you feel that are the most impressive in terms of trees and so on? I mean, there are some pretty massive trees around. Are those the ones that you find the most impressive, or is it the venerable ones?
it's venerable. I mean, when as a child, I did see for instance, the redwoods and the sequoias, but I was very young at the time, and yes, they are impressive. Um, I'm just amazed at any organism that can persist so long and so well in the face of such adversity. Um, so, you know, if I had to choose a favorite, a place, I think it would have to be the Himalaya. It's
Yeah.
just because it's not only are these trees, really living in a dynamic zone. There's rock fall, there's ice fall, there's like all kinds of things falling. I mean, the Himalaya are still growing, right? So, and things are tumbling. Not only that, it's cold, steep, but you always have this backdrop of snow and ice behind them.
Mm. Oops, you've frozen. Just at the very moment. Um, you're still frozen. You'll come back in a minute. I don't know whether you can hear me. I hope you can.
I can.
You can.
Yeah.
Richard, I can hear you now, and you're back to moving again. I think it is the internet misbehaving itself. Richard asks, in Hayleywood, there are several twisted trees. Why do you think they do this? Why do trees twist?
Well, I have this theory that I think of what a whole colleague of mine in the U.S. Forest Service called the pipe model of tree physiology. That there. If you have a moment, look up Harry Valentine pipe model. Harry Valentine was a modeler, a tree modeler, for the Forest Service many years ago, and he had this concept, this conception of a tree where imagine a big bundle of straws, right? And each straw can go, all the straws go to different roots in the ground, and they're connected to branches. So you have one branch and a path going to the same root. And each branch has its own connection to a root. Now, let's say for some reason, a few branches on one side of the tree die, that pathway, that conduit from the ground to what was the photosynthetic factory of that branch has now been broken. And growth has to take over somehow. The tree has to compensate for that. So it begins this sort of twist. The spiral begins as a new pathway is found. It's kind of like you're remapping your brain. You lose your arm and your brain remaps itself. Well, now the tree is remapping in a sense. If we were in a small lecture theater, a large lecture theater in the department, I would go to the chalkboard at this point, and I would draw it for you. And you would see, so that kind of makes sense.
Yeah. Okay, next question. You said, I think, that some trees are complacent and don't respond much to climate variation, as much to climate variation as others. Can you give some examples, and why are they complacent?
Well, this has a lot to do with what's called the principle of ecological amplitude. So, imagine, you have a garden, and every day, you water it, and the plants in your garden are not want for anything. At some point, your garden will reach a sort of an ideal growing capacity of growth, and will maintain that. So long as you don't change the amount of water and nutrients you provide, the plants are very happy. This is the same thing with trees. In the middle of their sort of natural distribution, all things, being considered equal, about the only thing the tree has to worry about is competition from other trees, because they've got sufficient water, they've got sufficient light, and sufficient temperature. When you start, growing further and further away from that ideal sweet spot, then just a small change in, say, temperature or precipitation, if it's a xeric climate, can have a large impact. But in the comfort zone, where the climate variables, water and temperature do not vary much, or you don't find extremes, do not either turn completely off or come completely on, the trees are so complacent. There's really nothing much to drive them, to think any differently about the climate.
I think, Paul, we're going to have to call it a day now, because we're at 9:15, and we've struggled through. I do thank you for persisting and bearing with the situation, and I think everybody will congratulate you on your ability to hang on in there, and we got there in the end. And I just think it was a completely fantastic talk, great fun. I'm extremely envious of what you've been doing. I mean, what a lovely thing you get to do. That's all I can say. I've got dozens of questions I could ask, but I'm sure it'd be much better down the pub next time you're in Cambridge.
I would look forward to it. Thank you very much, Duncan.
Okay.
Thank you very, very much, Monica. It's nice to see you, Harriet. Lovely to see you, Tanya and Alma, and to see the names of all of my great friends, those many that I miss very much.